Good morning. It's so good to be in Florida. Um, Actually, last time I've been to Florida was about 10 years ago, and it was actually one of the first places where I talked about Angular before it really became what it is today. So it's kind of funny that, about not quite 10 years, but or something like that, 8 years later, we're back over here. So today I want to talk to you about Angular ngUpgrade, which is a library for helping you to get from AngularJS to Angular. So kind of get the terminology right. We refer to the Angular version 1x as AngularJS, and everything going forward we refer to as Angular, so that's 2 and higher. We even have 2 separate logos, as you can see. And it does get a little confusing, but we think that long-term, referring to it just as Angular is the way to go. So the question is, how do we get from AngularJS version 1 to Angular version 2 and higher? And we don't need to talk about 4 different things. Most obvious is how do we bridge the components so that we can use our components we have in AngularJS inside of Angular and vice versa. But the same thing also goes for services. And specifically, we also need to discuss how we're going to bootstrap the 2 frameworks together on a single page so they can be used seamlessly. And how you bootstrap actually has implications about how a change detection runs in these 2 frameworks. So we'll kind of discuss this more in depth. And the terminology we chose when we're discussing these 2 things is that when you have an AngularJS component or a service, and you want to use it within Angular, you need to upgrade it, so that you have to create a facade so that Angular can use it. So that's the upgrade process. And if you have a component or a service inside of Angular and you want to use it in AngularJS, you have to downgrade it. So it'll be that the AngularJS gets the facade from the Angular as well. So let's talk about components first. I wanted to give you kind of the background as how this thing works rather than just throwing at you the basic code. So imagine you have AngularJS and you have a component, let's say it's an office, and there's a template. When the framework sees it, it looks at the template and says, oh, there's a div in a person, and it goes and instantiates a div in a person for you. And then it goes ahead and runs the controller constructor function, which might do something, we don't know, because it's a third party. Let's say it creates a span and it inserts it in that location. And so what happens is this blue box is really outside of the control of the framework, of the AngularJS framework. It's some other third-party library that's doing this. But the 2 work kind of together seamlessly. And so what we can do then is we can take the stuff that's in the constructor and pull it up into a separate directive and say, look, we could just have a directive that says, if you come across a person inside of the DOM, then go ahead and bootstrap this third-party library. And specifically, as you can see where I'm going with this, the third-party library could be a downloaded component library that takes an Angular component and makes it available to AngularJS. So that's kind of the mental model of how this works, is that we create a directive that triggers the bootstrapping of Angular inside of AngularJS. And by the way, the same exact principle works in reverse as well. Now, in this particular case, we're assuming that there's already a component person. We'll show you later. There's this flag you can set called propagate digest. You can set it to false or true, and this sets up something we call ngUpgrade full or ngUpgrade light. And again, we'll talk about that more in depth. But it controls the way the change detection kind of works within the system. So this is basically the mechanism by which a component is made available to the other side. And the same exact thing kind of works in reverse. So the mental model that you should have is that each framework is responsible for creating its own DOM elements. And once a framework creates a DOM element, it is kind of owned by that framework. So the change detection, all the semantics for a particular DOM element are follow through whichever framework created it, whether it's Angular or AngularJS. So in reverse, we could take, you can say, like, let's say I have this office component, and I want to wrap it so that Angular itself can use it. So we have this upgrade component that we can extend from, and we create it, because in Angular, everything has to be a class with a annotation. So we created a person class that has the selector that triggers it. And then in its constructor, it says, go ahead and instantiate an AngularJS component, which has the directive name is office over here, and then brings it up. And so in this particular way, you can kind of nest the components. You can have a AngularJS component that actually instantiates Angular component, which in turn go ahead and instantiates AngularJS component. And you can kind of go back and forth on it. So that kind of sets up how components work. Now let's talk about services. Now, the services really is just an object. That in itself is not special. But what is special is that the services are available to you through an injector. And there's really two injectors, right? So AngularJS has its $injector that we all know and love. And in Angular, we have this concept of hierarchical injection. Specifically, we have a root injector, which let's call it my app root module injector. And what we'd like to make sure that happens is that the two injectors can see each other and they can resolve each other's dependencies. So what we need to do is we need to somehow set up this connection between the my app root module injector and the $injector from AngularJS. And so the way we do that, I'm actually going to show you the actual mechanisms. None of this stuff you really have to do yourself. It's all provided by the ngUpgrade library. But what happens underneath is that in AngularJS land, we set up a factory for a well-known token, in this case, $Angular injector, which refers to the instance of the my app module injector. And then we can go ahead and set up a factory for it says if somebody asks for my app, it's the same exact thing as going to the my app module injector and getting a my app by that token. Notice what we have to do is that Angular uses type as tokens, whereas AngularJS uses strings. So there's this kind of mapping that has to happen between a string and a type. And so to make all of this stuff easier, none of this stuff is something you have to write. It's all automatic. The line you have to write is the last line over here, where it simply says, I'm making my app as a string available to AngularJS, and I pass in, again, the downgrade injectable, and I pass in the token I want to make available for it. And so the ngUpgrade library does all of the individual setup behind the scenes for you. And the same exact thing works back in the reverse order as well. So if you have a $injector, and you want to provide it, you simply have a factory like this. Again, this is set up for you automatically. And then we can also provide, for example, a root scope so that you can inject that. And again, you can see that how we just get a hold of the other injector and then pull up whatever we need from the other location. So this basically allows us to, as you can see inside of the Angular world, inside of my class constructor, we can now inject things by its string, in this case the root scope, the way you would do it in AngularJS. Or it makes that the my app constructor, actually my app instance becomes available inside of the AngularJS world as well. So by bridging the injectors, you basically allow yourself to be able to inject services from either AngularJS or Angular seamlessly between each other. And the same exact thing happens in the reverse. So if you have a AngularJS service that you expose as a string, my service, then the other side can say, well, please provide me, notice this time I'm asking for a type, which internally goes and retrieves the my service as a string and makes it available so that when you use it inside of Angular world, instead of referring to it as a string literal my service with lowercase m, you can just refer to it by type and it automatically does the right thing. So by bridging the injectors and also providing mechanisms for going between the two sides, you get to seamlessly work with both sides of the framework. So the couple of things to keep in mind is that only the top-level injectors are bridged. And so any services that you want to have available on both sides, you have to place over there. And when we are converting between the other, from one injector to the other injector, we're not only creating a connection between them, but also we're matching the semantics, right? So in AngularJS, we retrieve things by strings. In Angular, we retrieve things by tokens, type tokens. So we bridge those as well. Now, the next thing to really kind of think about is, well, now that we have kind of showed you how to get components from both sides and how to get services from both sides, how exactly do we bootstrap the two frameworks? What we really want to do is that on a single page, we want to get both the AngularJS running and Angular running, and they have their components and maybe their services are shared as well. So I'll show you the actual code on how to get this done. But first, I want to kind of talk about it conceptually, which is that you might have a component A owned by AngularJS and component B owned by Angular, and they all are sharing services underneath it. Now, for Angular to run, it relies on something called zone.js, which is shown here in the green. And what it actually does is it says, look, any code that runs inside of this particular zone, if there is any asynchronous work I want to know about it so that I can do change detection at a later point in time. This is why in Angular you don't have to manually call $digest. It's just automatically done for you because of this Zone.js technology that's behind the scenes. Now, when you bootstrap your component in this particular way, this is what we call ngUpgrade Lite way. You have the advantage that the change detection only runs whenever something inside of component B changes. But because component B refers to services C and D, these two components may or may not be running inside of the zone, depending on whether they got invoked from component A or component B. And this is could be troublesome depending on what the components do themselves. So if the services do the basic stuff that the normal services do, usually it's not a problem. The trouble arises if, for example, component A would leave a callback with service C, and that callback would get triggered by component's B action. In that particular situation, you might get yourself out of the zone. And in that case, you will just manually have to say $digest to kind of get the system going again. But the advantage of this particular model is that it treats the applications as independent, and it has the two change detection systems separate. The other way to do this is to actually bootstrap both sides inside of a zone. And if you do it in this particular way, then Angular Zone knows about all of the changes that happen in the system, and it can perform the change detection at the right moment for you without any kind of surprises. The downside of this is that this might cause more change detections inside of your system than expected, and so it might have a performance impact. So we gave you this kind of a choice, and then if you look at it more in depth, there's a couple of differences between them. One is that the way you bootstrap with ngUpgrade full, in order to get AngularJS to run inside of Angular Zone, we have to bootstrap Angular first, and then into it we load AngularJS. So both of the frameworks have to be available on the page at the same time. Whereas if you look at ngUpgrade Lite, there we bootstrap AngularJS independently, and we can usually bootstrap it first. And then we can lazily, perhaps when you visit a specific route, and only that particular route is implemented using Angular, only then do we need to bootstrap Angular itself. And so by doing things lazily, you give better experience to the user. So from a zones perspective, in the full mode, both Angular and AngularJS run in the zone, whereas in the ngUpgrade Lite mode, only the Angular components run in the zone. And the services run kind of in the mixed mode, depending about who invoked them, whether they get invoked from AngularJS or from Angular itself. Now, the mental model you want to think about it is that in ngUpgrade full, really the two frameworks are integrated tightly and interleaved, and I'll show you that in a second, that you're really thinking about a single application running on a page. Whereas in the ngUpgrade Lite, you really have two separate applications running next to each other. And because they're two separate applications, you get benefits of running their change detection systems independently from each other. And because the change detection can be run independently, you can get performance gains. So we talked about the change detection being interleaved or separate. And the benefit is in ngUpgrade full, it's very predictable in the way the system behaves, versus the ngUpgrade Lite, the benefit is that you can be faster. Because of that, if you want to look at the upgrade strategy in ngUpgrade full, you can upgrade yourself any way you want, top down, inside out, whatever works for you. Whereas in ngUpgrade Lite, I'm not saying it's required, but we probably recommend that you do it a route at a time so that you can treat each route as a separate sub-application that gets loaded into the system. So let me show you how that affects change detection systems. So here you have a ngUpgrade full, in which case notice that the dollar scopes are interleaved with the orange box, in this case is Angular. So notice that they're nicely interleaved. So as change detection happens from the root and propagates down to the child scopes, it goes and visits a change detection in the Angular downgraded component so that it can be executed as expected. On the other hand, if you do ngUpgrade Lite, now this particular component, it's still in the same location in the UI. The UI hasn't changed anything at all, but it has a separate lifecycle basically for itself. And it runs its change detection separately from the change detection of the application. This is why we're saying that now it's more like two separate applications being on the same page that are independent of each other. And this is why, while it's not strictly required that the two child components of the Angular component, the cyan and purple, I guess have to be children of the change detection, it's probably a good idea because it makes for a more predictable system. And this is why we're saying that you should probably look at it as a one route at a time kind of upgrade strategy. So just to kind of review the ngUpgrade full, you really want to bridge the change detectors. The change detections are interleaved, and everything runs in ngZone, whereas in ngUpgrade Lite, the two change detectors are independent. Only Angular runs inside of a zone, and because of that, you can have lazy loading and so forth, the other benefits. So let's look at some code. This is a standard way of bootstrapping AngularJS application that you have seen many, many times before. You just simply call Angular Bootstrap, you pass in some HTML element that gets it going. So how does this change when we want to bootstrap both of the applications, both of the frameworks at the same time? So this is the line that kind of is in question. So let me show you first the full mode. In a full mode, the first thing you do is you replace the line by the equivalent Angular way of bootstrapping, where you say, grab the browser and bootstrap the component. This example uses the dynamic mode, but the full AOT compiled mode is the same exact syntax. So here we bootstrap ourselves. Once we bootstrap ourselves, we have a root module, which depends on upgrade module. So we pull that in. And here is the place where we actually bootstrap AngularJS from within Angular. So we inject the upgrade module, and then inside of it, there is a bootstrap method that is identical to the bootstrap method on the previous slide. It just lives inside of the upgrade. We pass in the same signatures, and then this bootstraps AngularJS inside of the Angular framework. And it does all of the magic with the injectors, which we talked about earlier. So this gets you in the full mode, and because AngularJS is getting bootstrapped from within Angular module, you are automatically running all the code inside of Angular zone. So this is how we get the two zones to be fully bridged. Now, this is contrasted with bootstrapping Lite. So here we use the regular AngularJS bootstrap methods, as you can see. Nothing's different there. What we do is we provide an additional module called a ngDowngrade module. So here's the basic methods, right? Here's the module where we provide. And notice that it's in the closure, which means that this particular closure gets executed when a component, an Angular component that has been downgraded to AngularJS, when we come across an Angular component that needs to execute, we lazily go and initialize Angular itself. And you can have code in here that does, for example, lazy loading of the platform browser. Lazy loading of Angular itself inside of AngularJS, and bootstrapping it this way. And so this is why we can do lazy loading thing in here. But because AngularJS runs first, it is outside of the Angular's zone, because the Angular zone is not set up until after we execute the bootstrap method over there. So this is how you do declaring components in AngularJS. Let's say you have a footer component. The key thing over here is that you have to make it available through entry components. Now, the good news is the entry components feature will hopefully go away in version 6, so it will be simplified for you. But for now, you have to list it so that it can be lazy loaded. It's kind of the place where the compiler can be bootstrapped in. And once you have that, you simply use the downgrade component, which we talked about earlier, and you turn the footer component, which is an Angular component, into AngularJS's directive, which will do the bootstrapping automatically. And this is also when we will lazily go and load the Angular framework as well. So it's only when somebody goes and instantiates a to-do app footer component do we actually go and instantiate the Angular framework. Services, similarly, you just list them in your module to make them available. And then if you want to make them available to the other side, you use the downgrade injectable on the other side to make it available like so. The only thing to keep in mind is if you're using the ngUpgrade Lite, because the service is lazily created and initialized, if you ask for the logger before there's a component that caused the instantiation of the Angular framework, you might get an exception because you're asking for it a little too early. Here we have how we do it in the other way. So let's say we have a to-do item, which is an AngularJS component. We create a directive which has the same exact selector for AngularJS. We create a class which extends upgrade component, and we tell the facade which AngularJS component to bootstrap right over here. Once we have the facade, we simply include it in our declarations because it's just another component or a directive, just like you would expect, and we are free to use it wherever we want. And finally, to show you how we do the services, we just provide a injector that says, go get me a particular item, like in this case, to-do item service, and we provide it under an Angular token. In this case, it's a proper type. So we're bridging not only the injectors, but also the types from a string literal to a type information as well. And that is all.